Hello everybody, welcome into another lesson. So today we are going to talk about linear programming. Well, this kind of piggybacks off of the past two lessons where we were graphing systems of inequalities. Now, linear programming is when you have an objective function such as what you see here where c equals 2x plus 3y. That is called your objective function. And the inequalities, that system, are the constraints which are going against this function. In economics, especially when companies are trying to figure out their profits from one month to another, they would have an objective function, and then the constraints would be based on the time frame. They would be based on different costs of labor, different costs of running machines, and other different various costs that they might have had. That's what those inequalities would represent. So, to graph linear programming, you don't actually graph the objective function itself. That's not what you do. What you're going to do, though, is start by graphing your inequalities. So you have x is greater than or equal to 0. We'll start there. Well, that's going to be, of course, the whole positive x-axis. That'll be the whole right-hand side, the whole eastern hemisphere of the coordinate plane. Then you have y is greater than or equal to 0, which would now put you in the whole first quadrant. And then you have x plus y is less than or equal to 9. So since x plus y is less than or equal to 9, you need to go ahead and graph that line. And since it's got the equal to component, we'll have a solid line. So let's figure out the x-intercept and y-intercept. X-intercept, of course, would be at 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Solid dot there since it's equal. The y-intercept would be at 0, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, of course, you'll just draw a solid line to connect them. Now, you don't need to graph any further. There's a reason. Because your x values cannot be less than 0. They can only be greater than or equal to 0. And then your y values cannot be less than 0. They can only be greater than or equal to 0. So literally you're only going to graph the portion where of the x plus y is less than or equal to 9. Only graph the portion where it meets the other two criteria. Now, of course, what you're going to want to do is shade the region that meets all these criteria. So go ahead and convert this third inequality into slope-intercept form, which would give you y is less than or equal to negative x plus 9. Now, we need to shade the region that meets all the criteria. X is greater than or equal to 0. Over here, y is greater than or equal to 0, that being the whole first quadrant. And then you'd have y is less than or equal to negative x plus 9. That'd be below the blue line. So basically, you're going to shade this entire region in here, bounded by the two axes underneath this line. So you will shade this region here, and whenever you have a closed off region that's shaded, if it's closed off, it's going to be called a bounded region. You have a bounded region. You could think of it as it's bounded, it's closed in. If it were unbounded, you would be shading outside of the blue line all the way through the rest of the quadrant. and then this inequality would be y is greater than or equal to negative x plus 9. That would give you an unbounded region, but this is a bounded region since it's all closed in and shaded. Okay, that's great. We graph these inequalities. Now what are we going to do with them? Well, if you're applying this to economics and finding your profit margins and stuff, you're going to do what's called finding the minimum and maximum values, which would enable you to know when you made the maximum profit and when you were least profitable. Granted, those are not the only things that linear programming is used for, but that's a big application of it. So what I would do here, label your points. You have, of course, 0, 0 being the origin. You have 9, 0 being an x-intercept. And then you have 0, 9 being the y-intercept. So notice this forms a triangle, right? You have 3 vertices. As a triangle would have 3 vertices. To find your minimum and maximum values, you're going to take the coordinates of your 3 vertices and put that into your objective function. So we'll take c equals 2 times our x value of 0. We're going to put in the coordinate 0, 0. C equals 2 plus 0, 2 times 0 plus 3 times the y value of 0. Well, that, of course, is going to give you 0 plus 0. You have literally 0. Okay? And then you can put in 9, 0, right? So go ahead and put in c equals 2 times your x value of 9 plus 3 times your y value of 0. Well, that, of course, would give you 18 plus 0, which would give you 18. And then go ahead also put in your coordinate of 0, 9. So c would equal 2 times that x coordinate of 0 plus 3 times that y coordinate of 9, which would give you 0 plus 27, which would give you 27. So the biggest value you get, the biggest value you get here is 27 when you put those two values in. Your biggest value will be the maximum. That'll be the maximum value, is 27. And your minimum, the smallest you get, of course, is 0. That'll be your minimum. And then, of course, 18 falls somewhere in between. But your maximum value for this objective function would be 27. Your minimum value would be 0. So we'll do a few more exercises like this. I think linear programming is really neat, personally. I only have like 5 examples today, so this shouldn't be a super terribly long lesson, but I still want to be thorough. I want to teach it right and be thorough. Okay, next objective function is c equals x plus 4y. So we have c equals x plus 4y, which is your objective function. The constraints are that x is greater than or equal to 2. We have that x is less than or equal to 5. We have that y is greater than or equal to 1. And then we have that y is less than or equal to 6. So first thing you want to do is figure out your inequalities, right? I'm probably going to do all these in one color. It's going to be a lot easier that way. So if x is greater than or equal to 2, that means you have the equal to component. You'll draw a vertical line through x equals 2. Right? And then you have x is less than or equal to 5, so that'll be another vertical line through x equals 5. Okay, so far we have our region there. Now, we have y is greater than or equal to 1. Well, we've already defined our x areas, right? Y is greater than or equal to 1. So we're going to draw a vertical line through y equals 1, but we're only going to focus on the portion where x is greater than or equal to 2 or less than or equal to 5. So you'll draw a vertical line through there, and actually we can delete everything further south of that, because we're not even concerned with anything below y is less than or equal to 1, or y is greater than or equal to 1. We're not concerned with any values of y being less than 1. Then we have y is less than or equal to 6, so between the values of x equals 2 and x equals 5, you'll draw a vertical line through y equals 6. So it'll go like that, since you're only going between x equals 2 and 5. And then you can erase everything north of there, because you literally only care about those certain values. Okay? Of course, do yourself a favor, label your coordinates, which would end up putting you at 2, 1. You'd have 2, 1, right? Because x is greater than or equal to 2, but y is greater than or equal to 1. You would end up having 5, 1 as a coordinate, because x is less than or equal to 5, but greater than or equal to 1. Then you'd end up having y is greater than or equal to 1. Well, I'm sorry. You have x is greater than or equal to 2, but y is less than or equal to 6. So you would actually end up having the coordinate 2, 6. And then over here, you would end up having 5, 6, because x is less than or equal to 5, and y is less than or equal to 6. So you got your 4 coordinates now. Now we need to shade the appropriate region. So x is greater than or equal to 2, which will be over this way. X is less than or equal to 5 will be this way. Y is greater than or equal to 1 and less than or equal to 6. So you're going to shade inside of this box right here. That'll literally be the region you shade. You have another bounded region, because the shaded region is enclosed entirely. That's why it's another bounded region. We'll have some unbounded regions, I'm sure, but not yet. Now, we want to figure out when we're the maximum what are the maximum value and the minimum value. So let's put in the 0.21 into our objective function. Put in the x value of 2 plus 4 times our y value of 1. Well, that's going to give you 2 plus 4, which would give you 6. Okay? Now why don't we put in 5, 1? So put in the x value of 5 into your function plus 4 times your y value of 1. That, of course, would give you 5 plus 4, which would give you 9. And then, let's put in 2, 6 into our function here. C equals that x value of 2 plus 4 times that y value of 6, which would end up equaling 2 plus 24, which would give you 26. and then put in 5, 6 into your objective function. So c would equal the x value of 5 plus 4 times your y value of 6. Well, that'd be 5 plus 24, which would equal 29. So your smallest value is definitely 6. There's your minimum. That's your minimum. And then you have a value of 29. That's going to be your maximum. So the minimum value for this objective function would be 6. The maximum value would be 29. I got a few more examples here. All right, what's the next one? So we have c equals 2x plus y for your objective function. So there's your objective function. We have x is greater than or equal to -5. We have x is less than or equal to 0. We have y is greater than or equal to -2. And then we have y is less than or equal to +2. So let's go ahead and graph our inequalities here. So x is greater than or equal to -5. That'll be a vertical line going through x equals -5. So we'll go right about there. X is less than or equal to 0. That'd be a vertical line through x is 0. We can just use the x-axis for that. That's great. Now, y is greater than or equal to -2. You're going to draw a horizontal line through y equals -2, but only from the point where x equals 5 to x equals 0. So it's going to look a lot like that. And then y is less than or equal to 2. Again, you're going to draw a horizontal line from x equals -5 to x equals 0. So there you go. And then the other part of that vertical line we can go ahead and erase. We're only concerned with y between -2 and +2 and equaling those. Now, we need to find the region to shade. X is greater than or equal to -5 that way. X is less than or equal to 0 this way. Y is greater than or equal to -2. Y is less than or equal to 2. So what you're going to end up doing is shading in here. Of course, you can imagine that this whole rectangle is shaded. I'm just trying not to destroy my axis completely, that's all. That's why I don't literally shade the whole thing, because I'd like to keep my axis lines intact. But now, of course, go ahead, plot your points. Then here you have -5, 2. Here you have 0, 2. Here you have -5, -2. And then here you have 0, -2. So take the coordinates of your vertices, you can figure out what your maximum and minimum values would be. So let's start with, for the objective function c, let's put in for 2x plus y, let's take our x coordinate of -5, put that in, plus our y value of -2, which would end up giving you -10 minus 2, which would equal -12. All right, now put in 0, negative 2 for your objective function. So 2 times 0 plus that negative 2, that's going to equal 0 minus 2, which would of course give you negative 2. Now let's put in the coordinate negative 5, positive 2 for our objective function. So 2 times negative 5 plus 2, well, that's going to, of course, give you negative 10 plus 2, which would give you negative 8. And then put in 0, 2 for that objective function. So 2 times 0 plus 2 would end up giving you 0 plus 2, which would equal 2. So notice your smallest number is negative 12. Negative 12 here would be your minimum. I'll call that mini. And then positive 2 would be your maximum number. So your minimum number, your minimum value for this would be negative 12. Your maximum value would be positive 2. And you have another bounded region. Just again, try not to completely destroy this. All right, what do we got next? So we have the objective function c equals negative 2x plus y. We have the constraints that x is greater than or equal to 0. We have that y is greater than or equal to 0. We have x plus y is greater than or equal to 7. And then we have 5x plus 2y is greater than or equal to 20. So those are the 4 constraints against the objective function. Well, I think we need to graph these first. So if x is greater than or equal to 0, it's a vertical line through x equals 0. That's just your entire x-axis. So it's going to be everything to the right. And then you have also at the same time y is greater than or equal to 0. So that'll be the whole first quadrant now would fit that region. Then we need to figure out x plus y is greater than or equal to 7. Well, it's got the equal to component, so let's draw a solid line. So x-intercept, of course, would be 7, 0. 7. It'll be at 7, 0. Your y-intercept would, of course, be at 0, 7. 0, 7. So let's go ahead and graph that line. Then you have 5x plus 4y is greater than or equal to 20. So your x-intercept would be at 4, 0. And then you would end up having your y-intercept at 10, 0. Well, I'm going to give you a clue here. Ultimately, this is going to end up that y is actually greater than or equal to negative 5 halves x plus 10. You're going to shade above the line here that was produced. You'll shade above the line that was produced. And then you also have x plus y is greater than 7, greater than or equal to 7, which would turn into y is greater than or equal to negative x plus 7. So it's going to be above both lines. If it's going to be above both lines, that means you don't need this portion of x plus y equals 7. And then, if it's going to be above both lines, because notice the 5x plus 2y greater than 20 fits inside of the x plus y is greater than 7, you actually don't need this portion of the 5x plus y equals 20. So yes, it is very common to get some funny shapes. So, what happens here? At this point where those two lines come together, the x plus y greater than or equal to 7, and 5x plus y is greater than or equal to 20 actually becomes a vertice, which would occur at the point 3, 5. That's actually a vertice. And then you have 0, 10, which is a vertice. And then you have, of course, 7, 0, which is a vertice. Now we need to figure out where we're shading. Where are we going to shade? So let's start with x is greater than or equal to 0. That would put us over in the whole right hemisphere. Y is greater than or equal to 0. That would give us the whole first quadrant. And then for both of the other inequalities, you would have that y is greater than or equal to both of those. So you're actually going to end up shading everything but inside of here. You'll end up with a very, very large shaded area. You'll end up with a very large shaded area. Now, this goes on to infinity, right? If you have a setup like this where the shaded region is not enclosed, it's outside of an enclosed region, that's called an unbounded region. This is an example of an unbounded region. And since the unbounded region is in a positive quadrant, it's going to be impossible to find the maximum value because it goes on infinitely. But we can find the minimum value. Why don't we put in these 3 vertices here? So into your objective function, take c is equal to negative 2 times your x value of 0 plus your y value of 10, which would give you 0 plus 10, which would just give you 10. Now put in your vertice 3, 5. So c equals negative 2 times your x coordinate of 3 plus your y coordinate of 5, which would end up giving you negative 6 plus 5, which would end up equaling negative 1. And then, of course, put in your vertice of 7, 0. So negative 2 times your x coordinate of 7 plus your y coordinate of 0, that would just give you negative 14. And there's no way we can obtain the maximum value because this keeps going on and on infinitely. But we can sure say our minimum value is negative 14. So that would be the minimum value is at negative 14 since we have an unbounded region. Now, if we had an unbounded region here in the 3rd or 4th quadrant, we'd have the opposite problem. We could only have a maximum value but no minimum because it would keep infinitely going downward. So that's the thing about unbounded regions. Now, bounded regions, you'll have both a minimum and a maximum value, but for an unbounded region, you're only going to have one or the other. You're not going to have both, because it's going to become infinitely positive or infinitely negative. And, well, as we know, infinity is not defined because it never stops. Should only have a couple more, then we'll be done. All right. No to that one. No. Yep, about two more. So we have C for our objective function is equal to 4x plus 3y. So 4x plus 3y equals C. That's our objective function. We have the constraints that x is greater than or equal to 0, which starts off in the right hemisphere. Then you have 2x plus 3y is greater than or equal to 6. You have 3x minus 2y is less than or equal to 9. And then you end up having x plus 5y is greater than or equal to 20. All right. So let's graph our inequalities. X is greater than or equal to 0 would literally be the y-axis, the whole y-axis itself, and everything to the right of that. Now 2x plus 3y is greater than or equal to 6. Let's go ahead and graph that. Well, the x-intercept, of course, would be at 3, 0. The y-intercept would end up being at 0, 2. So we'll start there. We'll draw a line there. Then we have 3x minus 2y is less than or equal to 9. So you'll end up having the x-intercept would again be at 3, 0, but your y-intercept would end up being at negative 4.5. So that's going to give you this region here. And then you're going to end up having x plus 5y is greater than or equal to 20. Well, your x-intercept would be all the way at 0, it would be at 20, 0, which would be right here. Your y-intercept would be at 0, 4, which would be right here. And there's roughly your region. All right, so we need to figure this out here. X is greater than or equal to 0, we have a good grip on. 2x plus 3y is greater than or equal to 6. That's going to be everything above here. It'll be everything above here. And then the 3x minus 2y is less than or equal to 9. This is the only one I'd worry about converting into slope-intercept form. If you do that, you'll end up getting y is actually greater than or equal to 3/2 x minus 9/2. So that would actually put that above this line here. And then you have x plus 5y is greater than or equal to 20. That's going to put you above this line. So really, you have all greater thans. So you have the far northern line that it's all greater than. That's the only line you need to actually worry about then. That's the only one you're going to need to worry about in what region you shade there. And you're actually going to end up shading above the line. And you'll end up having actually another unbounded region. So label your vertices here, which would end up putting you at 0, 4, and then of course at 20, 0. And then you're going to end up having both a maximum and a minimum value. No, you'll have a minimum value because this will actually be an unbounded region, because you're going to shade everything above this line here. And as you see, since we're shading everything up here above the x plus 5, y is greater than or equal to 20, we're not going to be able to define the maximum value because it keeps going up and up infinitely. But we can sure take a crack at the minimum value. Let's start with the coordinate 0, 4. Put that into our objective function. So c equals 4 times that x value of 0 plus 3 times that y value of 4. Well, that's going to give you, of course, 0 plus 12, which would give you 12. All right, so now how about 20, 0? Put that coordinate in. C equals 4 times that x value of 20 plus 3 times your y value of 0. Well, that, of course, is going to give you 80 plus 0, which would just give you 80. Well, we can only find a minimum value since we have an unbounded region. 80 is definitely not our minimum. 12 is. So the minimum value would end up being at 12. That'll be at the value of 12 at the point 0, 4. That's where your minimum occurs. And I got one more exercise, then we're done. Sorry about kicking that, guys. Did not mean to. Going to have one more. Then we're done for the day. So let's see. We have the objective function c equals 10x plus 3y. So we're going to start there. You have the constraints that x is greater than or equal to 0, which will put you over in the eastern hemisphere. Then you have that y is greater than or equal to 0, which would actually end up then giving you the whole first quadrant. So we're going to be in the first quadrant for sure. Now there are three more constraints. You have negative x plus y is greater than or equal to 0. You have 2x plus y is greater than or equal to 4. And then you have 2x plus y is less than or equal to 13. So we need to graph all of these inequalities. Well, the x is greater than 0 is our whole y-axis. The y is, it's supposed to be greater than or equal to 0. I almost wrote less than or equal to 0 for the y. Y is greater than or equal to 0 will be the whole x-axis going right, so you have the first quadrant. Now let's figure out negative x plus 0. Of course, you have the point 0, 0. And then, of course, you end up just going up and up and up. So 1, 2, 3, 4, 5. Let's go to 5, 5. I'm just picking random points here. That's what negative x plus y greater than or equal to 0 would look like. We don't need, I was just kind of plotting that point just for a second to help me. Then you have 2x plus y is greater than or equal to 4, so your x-intercept would be at 2, 0. And then you have your y-intercept would be at 0, 4. We can draw a line to connect those. Then 2x plus y is less than or equal to 13, making your x-intercept 13 halves, which would be 6.5, 0. Which would go right there, and your y-intercept at 13, 0. Which would actually end up coming right to here. Alright, so we've graphed all those inequalities. Let's figure this out a minute here. Negative x plus y is greater than or equal to 0. So we're definitely going to have above this line. So anything here below the x, negative x plus y is greater than or equal to 0, we can get rid of. We can totally get rid of that, because we're only going to be caring about what's above that. Now, 2x plus y is greater than or equal to 4. It's going to be greater than or equal to, so we're only going to care what's to the right of this little sliver. So we can actually get rid of this part of negative x plus y is greater than or equal to 0. You're going to end up getting a really weird shape, because we're only going to care about this little sliver of 2x plus y is greater than or equal to 4 to the right. Then you have 2x plus y is less than or equal to 13. Well, you're only, again, going to care about what's below this line, but above the other two. So you're going to definitely go ahead and erase everything below the 2x, erase everything below the negative x plus y greater than or equal to 0, because you don't care about that value. And you're going to stay below 2x plus y is less than or equal to 13, so you can actually erase this whole part of negative x plus y is greater than or equal to 0. So there's your region. There's your entire region. Let's go ahead and graph the vertices. You have, of course, 0, 4. Let's see, man, what part was that? That was, well, this for sure is going to be 5, 5. That's 0, 13. And then you end up having this right here. That'd be about the 0.22. All right. I'm not the best at drawing, but there's your vertices. Now we got to figure out the region we're shading. So x is greater than or equal to 0, y is greater than or equal to 0, negative x plus y is greater than or equal to 0, that'll be above here. 2x plus y is greater than or equal to 4, that'll be above here. 2x plus y is less than or equal to 13, that'll be below here. So we're going to shade this entire region. So yes, there is our 4 vertices. Now we need to, since this is a bounded region, we need to figure out both our maximum and minimum values. So let's take 0, 4, put that in. Just take, of course, c equals 10 times your x coordinate of 0 plus 3 times your y coordinate of 4, which would end up giving you 0 plus 12, giving you just 12. Now take 2, 2. C would equal 10 times your x coordinate of 2 plus 3 times your y coordinate of 2, which would end up giving you 20 plus 6. That'll give you 46. Then put in 5, 5 for your coordinates. C equals 10 times your x coordinate of 5 plus 3 times your y coordinate of 5. So that would end up giving you 50 plus 15, which would end up giving you 65. And then last but not least, you would have the coordinate 0, 13. So C equals 10 times your x coordinate of 0 plus 3 times your y coordinate of 13, which would be 0 plus 39, which would just give you 39. So your minimum value actually occurs at 0, 4 when you have a value of 12. So the minimum value is going to be at 12, and then 65 is clearly your maximum value at the 0.55. So 65 is your maximum value at the 0.55. So that's it for linear programming. The very next lesson, we're going to get into graphing 3D equations. We're going to do a little bit of graphing in 3D. We'll plot points in 3D. We'll introduce the x, y, and z axes of the Cartesian coordinate plane. We'll plot some points. We'll draw some triangular planes. And we'll even do some functions of 2 variables. A multivariable function. So I hope everyone has a great night. Take care.